Hello viewers, my name is Damilare. In this lesson, we'll be looking at the topic alkanoic acids. What are alkanoic acids? They are organic acids. When we say organic, we mean something we can get from plants or animals, or you say natural source. Then this alkanoic acid contains carboxylic group, that's COOH. This carboxylic group is known as the functional group. That means anywhere you see alkanoic acid, you'll be seeing COOH, COOH. So that is the functional group, just like a badge, a logo. Then alkanoic acid has what we call aliphatic, and it also has aromatic. The aliphatic from the letter L, it means those ones that are linear. For example, this is a metanoic acid. So this metanoic acid is an aliphatic carboxylic acid. And the example, we have metanoic acid, we also have ethanoic acid. They are all aliphatic. Then we also have aromatic. You can use the letter R to remember ring. Aromatic, they are always in ring form. As you can see, this benzoic. This is benzene with COOH, making it benzoic. So the GMF is RCOOH. That's the general molecular formula of alkanoic acid, RCOOH. Then what's the source? Where can we get alkanoic acid? For example, metanoic acid, we can see it in ants. For example, at night when you are bitten by ants, so you feel a pain, it's as a result of the metanoic acid that is put in one's body. Ethanoic acid also, that one can be gotten from vinegar. Then we have palmitic acid. This is hexadecanoic. Hexa means 6, deca is 10. Total number of 16, so it means the alkanoic acid in number 16 is hexadecanoic. So this is palmitic acid, and we can find it in palm oil. Now another thing we want to look at is how you pack name of this alkanoic acid. The first one is metanoic, that's number 1. So once we put the number 1 in the general formula, this is the general formula RCOOH. And take notes, in any general formula you see, once C is already in the general formula, the fastest method of knowing number 1 homologue under it is that once there is C, just put H at the back. That will be the number 1. So meaning this is number 1, called metanoic acid. And if you want to do number 2, you keep adding CH2. So keep adding CH2 to each of them. So if this is number 1, if I add CH2, it will make it CH3. So it means CH3, then COOH. That will be the number 2, meaning that there are 2 carbons here. So, and that's our ethanoic acid. If you want to get the number 3, propanoic, add CH2 again to this CH3. It will turn to C2H5. So that's C2H5 including the COOH. So C2H5 including the COOH. So it will give us propanoic acid and so on. But our case study will only be on metanoic and ethanoic. So for the metanoic, which is the first one, that's HCOOH. So where this C here has H at the back, then O at the top. Take note, there is double bond here before you write your O, because O has oxidation number of -2 or valency of 2. So meaning there must be double bond in O. So, and sometimes you see we write O 2-, meaning that the bond around O must be 2. So that's why this O has double bond. Then you also put OH underneath it here. So this is OH. So meaning for metanoic, you can write the structural formula in this form, HCOOH. So where the C here, you can see it has single bond at the back, double here, and another, making 4. 1, 2, 3, 4. Because around every carbon there must be 4 bonds. The reason is that carbon belongs to group 4. So this is how to draw the structure of metanoic acid. Then if you want to write the molecular formula, first write CHO for molecular formula, CHO, that's like CHO. So then you begin to count how many C do we have here. That's 1. So this is 1. How many H? This is H1 and H2. So that's H2 here. Then how many O? we have 1 and 2. That's why we have CH2O2 as the molecular formula. Then the common name is formic acid. So anything in number 1, we call it form. So that's formic acid. Then when we take number 2, ethanoic acid. So this ethanoic acid, as I said from what I said earlier here, that this is number 1, then this is number 2. So number 2 is ethanoic, CH3COOH. So this ethanoic, if I want to draw it in open form, it means I'll first put my C. This is my C. Then the O that is there will be at the top with the double bond here. Then OH will be together under it. Then this CH3 will be here, meaning that C will be here, H at the top, H under, H at the left. So that's CH3. So for our ethanoic acid, and because it's number 2, we call it acetic acid. So because anything 2 is acet, 1 is form. So formic acid for 1, acetic acid for 2. So you can continue the number 3, 4 in your evaluation. Now let's move to physical properties of ethanoic acid. So what are the physical properties of ethanoic acid? You can just use these mnemonics: BPTS-SCF, BPTS-SCF, just like saying Baptist, then the SCF like scarf, so Baptist scarf. So the B means boiling points. So the boiling point of ethanoic acid is 118. If you want to remember the total elements in a periodic table is 118. So meaning the BP of ethanoic is 118 degrees centigrade. Then the letter P. So P, we can use paper to remember P, meaning that ethanoic acid will turn blue litmus paper to red because it's an acid. Then the letter T, we can use it to remember the taste. The taste of ethanoic acid, it tastes sour because it's an acid. Then letter S, use it to remember smell. The smell of ethanoic acid is pungent, like choking, something that will make you to cough when you smell it. Then another letter S, so that is soluble, meaning ethanoic acid is soluble in water. Then letter C, that's colorless. When you look at ethanoic acid, it doesn't have color. Then F, so F, you can use freeze to remember. It means ethanoic acid can freeze. That's when the temperature is below 17, less than 17. So how will you remember this 17? From the boiling point 118, just take the 1 that is at the back of 118, subtract it from the 18 that is there, that's 17. So less than 17 degrees. When the temperature is that, so it will make it freeze. So that is the physical properties of ethanoic acid. Now we move to chemical properties. How will you remember the chemical properties of ethanoic acid? That's, you can say RAM, RAM, RAM. Then BAT, BATH, as if RAM is taking his bath. So the R, how will you remember R? R, we call it reduction. It means ethanoic acid can be reduced, and in redox reaction, hydrogen is what they normally use to reduce a substance. So meaning that H is the reducing agent of this ethanoic acid. So if I want to reduce ethanoic, so I will make use of this reducing agent, which I call lithium. This 4 here is tetra, so meaning lithium tetra. The H here hydrido, so lithium tetra hydrido aluminate 3. So we use it as our reducing agent, and that's why I will bring out H here. So because of the H4, it means I'll bring out 4H to reduce ethanoic acid. So and when you reduce ethanoic acid, it will turn to ethanol. Ethanol, just like in our homologous series, we have alkane, we have alkene, we have alkyne, that's YNE, alkyne. We have alkanol. After alkanol, we now have alkanoic acid. So we have alkanoic acid. So this alkanoic acid, if we reduce it, then it will turn to alkanol. Alkanoic acid will turn to alkanol, meaning that this ethanoic acid will become ethanol. So by reduction. And how will you remember the formula? Just take this ethanoic acid, you bring out the C that is here 1, another C here 2. So that's how we get the C2 here. Then the H that is here 3 plus the H that is here, that's 4. Then you pick another 1 here, that's 5. So that's C2H5. Then the OH, you can bring 1 O here, This is the O. Then the other H, you get it from here. Remember, we have taken one, so you take the other H here. So to form C2H5OH. Then the remaining things we have will now be water, because we have taken 2H from here. The remaining 2H and the remaining O will form H2O. Now another one is A. A means the addition of alkano. It means this ethanoic acid, I can add alkano, that's ethanol to it. So if I'm adding ethanol to ethanoic acid, it will give me ester. So this is the ester and the water. Now looking at this, remember this is an acid. H will be removed. This one is like a base. OH will be removed. So H and OH will give us H2O. That's water. Then the remaining C2H5 that is here, we will bring it to where H is leaving. So when C2H5 is coming here, meaning we will have CH3COO C2H5. The H and OH that was removed will turn to water. So that's for the A. A means addition of alkano. Alkano, that's ethanol, to give us this ester and water. And what's the name of this ester? From C2H5. So C2H5 is ethyl, because it's number 2. Anything that has 2 carbon is eth. So it's called ethyl. So ethyl, that's C2H5. Then because of these 2 carbons, 1 and 2, that's ethanoate. So we say ethyl ethanoate. So ethyl ethanoate. So that's the name of the ester that is formed. Then M. M, we call it metal. This is a metal, like K. K is a metal. So when we add a metal to an acid, we are expecting hydrogen gas. Hydrogen gas. So this metal K will be replaced. It will replace the H. That means K will replace H here. So we have CH3COK. Then the H that is here will be released as hydrogen gas. Then you start balancing it by saying CH3COO, CH3COO that is here. The H that is here is only 1, but the H that is here is 2. So to make it balance, you have to put 2 here. Then the K also, you put 2 here, so that it will be balanced. So that's for the metal. Then the next one is B. B means base. It means to our ethanoic acid we can add base. So and what is the base we are using here? That's NaOH. So NaOH is the base. So if we add this, it means from our ethanoic acid, the H here will be replaced by Na. So when Na comes here, we have CH3COO Na. So the Na is sodium, and because there are 2 carbons here, 1 and 2, we say eth. So that's sodium ethanoate. Sodium ethanoate. Then the H here and the OH will form water. So this base we added is an alkaline. So we can call it alkaline hydrolysis of this ethanoic acid. So that's for the B. Then another A is ammonia. Ammonia, meaning that we can add ammonia to this ethanoic acid. So adding ammonia will give us amide. There will be an amide. So how will it give us amide? From the formula of amide, amide is RCONH2. That's amide, RCONH2. So looking at this, it means when we get amide, so it means the R represents this methyl. So meaning that from this ethanoic acid, I'm going to remove OH. So when I remove OH, it remains CH3CO. The CH3 represents this R. Then this is the CO. So meaning that from the CH3CO, NH2 will be taken from here. So NH2 will be taken from here, remaining 1H. That 1H will join the OH and form water. So what's the name of this amide here? So this amide is called ethanamide. Ethanamide. And why is it called ethanamide? Because there are 2 carbons here. This is the first carbon and the second carbon. So that is ethanamide. Then after the A, we also have T. T means triazocarbonate 4. Triazocarbonate 4. From the triazocarbonate 4, like CaCO3 is a triazocarbonate 4. When we add it to ethanoic acid, the first thing we should note about acids and triazocarbonates, they always produce CO2 and water. So meaning if CO2 is coming out of this triazocarbonate 4, there will be 1 O left after removing CO2. So the 1 O that is left will be added to the H that is coming out of ethanoic acid. Remember, ethanoic acid always produce hydrogen. So the H and the O will give us the water that is here. So while the remaining CH3COO, they will be here. So the remaining CH3CO3, then the remaining CAA also will add to it. So this will give us calcium ethanoate. Calcium ethanoate. So that is for the T. Then the last one here is H. So the H means you are going to heat. You are going to heat ethanoic acid. Heating, that's burning. When you burn something, heating. So when you heat ethanoic acid, so what will it give you? So it will give us methane. Methane, that's CH4. You bring CH3 from here with the remaining H from here, that's CH4. Then the COO means CO2. So meaning that it's going to give us methane and carbon dioxide. So what you use to heat it is called soda lime. Soda lime. So once again, if you want to remember chemical properties of ethanoic acid, just use RAM and then BAT. That's RAMBATH. Then that leads us to uses of ethanoic acid. So what do we use ethanoic acid for? Use this mnemonic FSCEP, just like find and scepter. Scepter that a king uses. So F and sep. So the F means flavor. We can use ethanoic acid as a flavor. The S is solvent. We can use it as a solvent. Then C, use it for cellulose. Then E as ethanoate. So we can use it to produce ethanoate. Then P, we can use it to preserve. So ethanoic acid can be used as a preservative. So then finally, we also look at how do we prepare ethanoic acid. So to prepare ethanoic acid, you can see no, na, and noic. That's no, na, noic. The no represents alkano. So when you take ethanol, like C2H5OH, so just heat it or oxidize it. So oxidation of ethanol. So it will first give you ethanol. Ethanol, that's why we call it no, na. So the na, this is ethanol. Remember, ethanol is something that has two carbons and the CHO. CHO is the logo of alkanal. So this ethanol is formed from the oxidation of ethanol, meaning when you add, remember this CH3CHO, it has two carbons. So you get the two carbons from this ethanol. Then the H here, there are 4. H3 plus 1, that's 4. Meaning you take 4H from this ethanol, remaining 1H, and the other H here, that's 2, and this O. So and that's water. Meaning that it will give us this ethanol separately and then water. So this is the ethanol written here and the water. But the ethanol is what we need. So when we take the ethanol we need and still oxidize it again, it will now give us ethanoic acid. Meaning that this one O and this second O will come to the middle here to give us COOH. So that is for the first preparation. Then the last preparation of ethanoic acid in the industry. So we use ethane C2H2. So like I wrote here N and Y. The N represents nonanoic. The Y, that's our ethane. So you can see 9 NY in 9. So to remember 9. So why the ethane C2H2, we can hydrate it. We can add water to ethane. So when we add water to ethane, it will first give us ethanol. Ethanol, that means from this C2 we have 1 and 2. The H2, the H2 here plus the H3, that's 4. Meaning that H3 and 1H here is also 4. Then the O here will be here. So since it has given us ethanol, then we continue with the same thing we said here, that ethanol with oxidation of ethanol, that it will now finally give us ethanoic acid. So and that will be the final result of this. So thanks for listening.